In this video, we're going to draw the ground state electron configurations for the following elements: sodium, tin, vanadium, and krypton. So let's begin with sodium. So you have I for sodium. Now if we find that on the periodic table, which is right here, we're going to see that it has a total of 11 protons, which also means that it has 11 electrons. We can also see that based on where it's at in the periodic table, we see that it ends in this block over here. Let's do green. So this is going to be considered our S block. The middle here, it's going to be considered our D block. And this block over here is going to be our P block. So that's going to help us to kind of foreshadow where we should end with each of these. So since we know that sodium has 11 electrons, it's also in this S block. It happens also to be in our level number. We have 1 here, 2, 3, 4, 5, 6, 7. Because it's in our third row and in our first column, we know that it should end with a 3s1. Now let's show what that looks like. So our ground state electron configuration, the first place we'll start is with our 1s, which is here, our 2s, which is here, our 2p, which are those 3, and then finally our 3s. So we know we only have 11 electrons. So let's start to fill up each of these following our rules, Hund, Aufbau, and Hunt rule. So we're going to start with this one. We'll go 1, 2 electrons, 1, 2 electrons. Now for P, we'll fill up each one by itself first, then we'll come up in pair. So right now we have 2, 4, 6, 8, 10. We only need one more electron, and that will go into our 3s. It can be pointing up or pointing down, it does not matter. But that would be our ground state electron configuration for sodium. Now let's move on to something that's a little bit more challenging, and that's going to be tin, Sn. So let's find that on our periodic table. That's going to be right here. So we could see that it has 50 number of protons, which means it's got 50 electrons. So we know that we need to end up with our 50 electrons. And then kind of using that same principle, we know this is going to end in a P, so we're going to put a P. It's on our 5th row, so we know it needs to end in 5P. And in our P row, it's going to be 1, 2 over. So since it's 2 over, it's going to be 5P2. You see that right here. So we have 1, 2, 3, 4, 5, and then 6 for our noble gases. All right, so we need to end in 5P2. So we have to get through quite a bit to land there. So let's start with our 1s. That's going to be 1, 2. Next is our 2s, which is going to be 1, 2. Next is our 2p. That has 3 orbitals, and we'll fill those up. 1, 2, 3, 4, 5, 6. We also have our 3s. Fill up with 2. Next, we're going to have our 3p. So we'll have 3 orbitals there. Fill those up. 1, 2, 3, 4, 5, 6. Next, we're going to move on to 4s. 1 up, 1 down. We then have our, before we move on to 4p, we'll actually do 3d first. And that has 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we'll go on to our 4p, which has our 1, 2, 3 orbitals. Let's fill those up correctly, which will give us 6 electrons. We'll then go on to 5s, which has our 2 electrons. We'll then move on to 4d. So similar to our 4s and then 3d transition, we're going to go from 5s to 4d. And that has 5 orbitals. Again, let's fill these up the correct way. going 1 in each space first, and then coming back to fill them up. And then we're going to move on to our 5p. Still has those 3 orbitals. And we see from up here, and we know that we should end in 5p, specifically 2. So we're going to fill these up, 1 in each first, and that's going to be our 2. Now we can go back and we can count each of these. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 51, 52. Oh, I think I messed up counting. Back to 50, excuse me. Just 50. Yep, 51, 48, 49, 50. That's where I messed up. So we only have 50 electrons, which is exactly what we're looking for. All right, now let's do vanadium. So 3. So let's go back to our periodic table, which is up here. If we find vanadium, it is here in the middle, number 23. So we see that it has 23 electrons, so it must, or protons, so it also must have 23 electrons. Now as we look at our D block, same rules apply like we did for our S and our P block. We'll call this 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we'll know that it should end in a D3. Now the D block is a little bit different from the other ones. Normally we would just say, oh, it's in the 4th row, it should be a 4D3. But these ones are actually shifted up just a fraction. So whatever your energy level is for the D, just subtract 1. It's kind of the same reason that you saw back here. We went from this 4S down to a 3D and then back to a 4P. That's because those Ds really should be shifted up a little bit. So this is going to end up as a 3D3. So now let's go through and start to fill in our orbitals. So we start with 1s, 1 up, 1 down. 2s, 1 up, 1 down. 2p, we have our 3 orbitals. Fill each one and then come back and double up. Then we're going to have our 3s, 1 up, 1 down. Our 3p, 1, 2, 3. Again, fill each level first, then come back and double up. We have our 4s, 1 up, 1 down. And now we'll end at our 3d. This has 5 orbitals. And we need to take those 3 electrons and put 1 in each level first before we go back and double up. So now let's count correctly this time. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 22, 23 electrons, which matches what we knew there should be. So perfect. All right, our last, but not our least, which is krypton, Kr. So we can find that again in our periodic table. It's a noble gas, so it's all the way on the right side. And it is number 36, meaning it's going to have 36 electrons. Also, it ends on the far right-hand side of our periodic table. So it should have everything completely filled. So that will make it a P6. And then we just look at which energy level it is in 4. And since it's in the P block, it matches that energy level. So this will end in a 4P6. So let's go through, let's plug them in. So we have our 1S, we have our 2S, our 2P, we have our 3S, we have our 3P, 1, 2, 3. We have our 4S, which is just 2 electrons. We go back down to our 3D, 1, 2, 3, 4, 5. Fill each one first, then come back and give them pairs. That will then move us on to 4P. Move it down. So 1, 2, 3. And this has 6. So 1, 2, 3, 4, 5, 6. Let's go back and count these just to make sure that we're correct. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. Perfect. So by using our periodic table, we can determine first how many electrons we need total. So we need 36 here, 23 here. We can also use that to determine which block our element is in, whether that's the D block, the P block, or the S block. And finally, its position in that block, we can see how many electrons it has on the outside. So whether that be 6 or whether that be 3. And then depending on whether it's in the S or the P block, we know that it matches the energy level row that it's in. So whether that's a 4, a 3, or a 2. But what's different is if it's in the D block, it's going to be your energy level minus 1. So that would be, even though it's in N equals 4, it's going to be a 3 T3 block.